In October 2024, soldiers from the 101st Airborne Division did something extraordinary in the mountains of North Carolina. They loaded vehicles into CH-47 Chinook helicopters and flew 350 miles through devastated terrain to deliver critical supplies to Hurricane Helene victims in Asheville. But here's what made this mission different. The vehicles they used weren't military trucks. They were built in a NASCAR factory, with roll cages designed by the same engineers who keep race car drivers alive at 200 miles per hour. And they're based on something you can buy at your local Chevy dealership. This is the Infantry Squad Vehicle, and it represents the most radical shift in how America equips its military in over 30 years. The Pentagon took a $35,000 pickup truck, stripped it down to the frame, and turned it into a weapon system that can carry 9 fully equipped paratroopers, fit inside a helicopter, survive a 20-foot drop, and now mount a laser weapon that shoots drones out of the sky. And they did it in 18 weeks. While China and Russia spent billions developing new military vehicles from scratch, the US took a different approach. They went to a Hendrick Motorsports shop in Concord, North Carolina, the same place that builds championship-winning race cars, and asked a simple question. What if we stopped thinking about military vehicles as custom-built machines and started thinking about them as modified race cars? The answer is rewriting the rules of modern warfare. For decades, the US military followed the same playbook for vehicle development. Custom design, specialized parts, years of testing, billions in contracts. The problem? By the time these vehicles reached the battlefield, they were already outdated. Take the Joint Light Tactical Vehicle, the JLTV. Development started in 2006. It didn't reach full production until 2019, 13 years to field a vehicle that was designed before the iPhone existed. Meanwhile, on actual battlefields, soldiers faced a different problem entirely. In Afghanistan, infantry units would helicopter into remote mountain positions. Then they'd walk everywhere, carrying 80-pound packs across brutal terrain because their vehicles, the armored Humvees and JLTVs, were too heavy to fly into position and too slow to keep up with air assault operations. The paratroopers of the 82nd Airborne could jump from a plane with pinpoint precision. Then they'd spend the next 6 hours marching to their objective while the enemy repositioned. Special Operations Forces had light, fast vehicles, but there weren't enough to go around, and they couldn't carry a full 9-soldier squad, the basic building block of Army infantry. The Pentagon tried to solve this with the Ground Mobility Vehicle program in 2015. They went to defense contractors and asked for proposals. What they got back were vehicles that cost $400,000 each, required custom parts with 18-month lead times, and still couldn't be built fast enough to equip all 35 Infantry Brigade combat teams. Then someone asked a dangerous question. Why are we building these from scratch? In 2018, the Army split the program into 2 phases. Phase 1 went to existing defense contractors. Phase 2, the Infantry Squad Vehicle program, went in a radically different direction. They gave companies just 6 months to design, build, and test prototypes. 3 teams competed: General Motors, Oshkosh Defense, and a SAIC Polaris partnership. GM showed up with something nobody expected. They rolled into Aberdeen Proving Ground with what looked like a Chevrolet Colorado pickup truck with a roll cage welded on. Pentagon officials were skeptical. This was a civilian truck. How could this possibly meet military requirements? But when the testing started, something remarkable happened. The GM vehicle did things the other prototypes couldn't. And the real shock came when they looked at the price tag. To understand why the Infantry Squad Vehicle matters, you need to understand what makes air assault operations so difficult. The CH-47 Chinook helicopter is the backbone of Army vertical maneuver. It can carry 33 troops or 24,000 pounds of cargo. But here's the constraint. The cargo bay is only 30 feet long and 7.5 feet wide. Most military vehicles don't fit. The Humvee fits, barely, but it's 5,900 pounds empty and sluggish off-road. The JLTV is faster and better protected, but it's nearly 15,000 pounds. You can sling load one under a Chinook, but you can't put it inside. And sling loading is slow, dangerous, and limits your tactical options. What the Army needed was something that could carry a full 9-soldier infantry squad, the same number as a Chinook, in a vehicle light enough to fly inside the helicopter, fast enough to keep pace with air assault operations, and tough enough to survive military use. And they needed it cheap enough to buy in bulk. Not 649 vehicles, not 1,000, but enough to equip every single infantry brigade combat team in the force. Over 2,500 vehicles. Previous attempts to fill this gap had failed spectacularly. The Army spent years developing the ground mobility vehicle, only to buy a tiny number because costs spiraled. Special Operations had their own fast vehicles, but they were expensive, limited in capacity, and not designed for conventional infantry units that operate in squad-sized elements. Here's what they missed. The technology already existed, not in a defense contractor's lab, in the off-road racing world. The Chevrolet Colorado ZR2 was designed to compete in the Baja 1000, one of the most brutal off-road races on Earth. It had Multimatic DSSV dampers, originally developed for Formula One racing, electronic locking front and rear differentials, a chassis built to handle jumps, rocks, and desert terrain at high speed, and it cost $35,000. GM Defense looked at this platform and saw something the traditional defense industry had missed. Instead of spending 5 years engineering a vehicle from scratch, they could take proven commercial technology, modify it for military requirements, and deliver vehicles in months instead of years. The question was, could a civilian pickup truck actually survive military use? GM Defense started with the Colorado ZR2 chassis, but what they built on top of it is where the genius really shows. Layer 1. The NASCAR connection. The Army required a rollover protection system that could survive a 20-foot drop and a full vehicle rollover. Standard military vehicle cages are welded steel frames, heavy, time-consuming to build, and requiring specialized military contractors. GM Defense went to Hendrick Motorsports instead. Yes, that Hendrick Motorsports, the winningest team in NASCAR history. The same engineers who design roll cages that keep drivers alive in 200-mile-per-hour crashes. They designed a chrome moly steel exoskeleton for the ISV using the exact same materials and techniques from NASCAR Cup Series cars. The welds are done with TIG welding, gas tungsten arc welding, the aerospace-grade process that's slower but stronger than traditional military vehicle construction. And here's the kicker. Hendrick's facility is in Concord, North Carolina, right next to the GM Defense production plant. Parts move between the two facilities in minutes, not months. The result? A roll cage that's lighter than traditional military designs but stronger than anything in its weight class. The ISV tips the scales at just 5,000 pounds fully loaded, light enough for a UH-60 Blackhawk to sling load it, and compact enough to fit two inside a Chinook. Layer 2, the performance package. Remember, this is based on a $35,000 pickup truck, but the production ISV isn't stock. The 2.8-liter Duramax turbo diesel gets modified to automatically sense and adjust for multiple fuel types. The military runs on diesel, JP8, and F24 fuel depending on what's available. The ISV adapts on the fly. Then they added combat mode. In civilian vehicles, when something goes wrong, the computer puts you in limp home mode to protect the engine. That's great when you're trying to make it to a repair shop. Catastrophic when you're trying to escape an ambush. Combat mode disables every safety limiter, every electronic nanny, every restriction. If soldiers need to push the vehicle past its normal limits to survive, combat mode lets them do it and deals with the consequences later. Power jumps to 275 horsepower and 420 pound-feet of torque. That's 89 more horses than the civilian ZR2, all from tuning and modifications that leverage the military's unique duty cycle. The suspension gets upgraded too. Rod Hall Products, legendary in off-road racing, provides modifications. The result is a vehicle that can maintain highway speeds on pavement, then transition to bounding across broken terrain without breaking stride. Layer 3. The speed of production. Here's where the commercial off-the-shelf approach pays off. 90% of ISV parts are COTS components, the same parts used in civilian Colorado ZR2s. That means GM's global supply chain kicks in. No waiting 18 months for a specialized military part. Break a suspension component? Order it from any Chevy performance dealer. The Army awarded the contract in June 2020. GM delivered the first production vehicles in April 2021. 10 months. From contract to fielding. By April 2023, GM had delivered over 300 vehicles. By October 2024, the 101st Airborne was using them in real-world disaster relief operations in North Carolina. By February 2025, GM received a new $45 million contract for additional vehicles, with the total acquisition objective now at 2,593 units. But wait, remember this detail. It becomes critical later. The ISV isn't just a troop carrier, it's a platform. Layer 4. The modular revolution. GM Defense designed the ISV with mission kits. Swap configurations in minutes, not hours. Need casualty evacuation? There's a CAS evac kit with stretcher mounts. Need heavy weapons? There's a weapons mount kit for M240 machine guns and M250 cal systems. Need command and control? The C2 ISV variant adds a protective shell with dual prick 158 radios, mission command terminals, and KGV-72 encryption. And then there's the variant that changes everything. In August 2022, the Army announced something that sounded like science fiction. They were going to mount a directed energy weapon, a laser, on the Infantry Squad Vehicle. Not on a Stryker, not on a JLTV, on a vehicle based on a Chevy pickup truck. The AMP-HEL system, Army Multi-Purpose High Energy Laser, puts a 20 kilowatt laser on the ISV platform. In September 2025, AeroVironment delivered the first 2 production units to the Army. These aren't experimental prototypes. They're operational systems deployed to protect infantry brigade combat teams from the threat that's redefining modern warfare: drones. Here's what that means on the battlefield. A single Shahed drone costs Iran around $20,000. Shooting it down with a Patriot missile costs $4 million. That's an unsustainable equation, but a laser shot costs between $1 and $10. And unlike missiles, a laser system has virtually unlimited ammunition, limited only by available power. The ISV-mounted laser can track and engage Group 1 and Group 2 drones, the exact threat that's plaguing forces in Ukraine and the Middle East. And because it's mounted on a platform that fits inside a Chinook, it can deploy with airborne forces directly into contested territory. Compare that to traditional counter-drone systems. The DEM SHORAD system, a 50 kilowatt laser on a Stryker platform, weighs 38,000 pounds. It's effective, but you can't fly it into position. The ISV gives you mobile laser defense that arrives with the first wave of air assault troops. The international market is taking notice. Canada ordered 90 ISVs in Phase 1, with options for 222 more to equip forces deploying to Latvia as part of NATO's enhanced forward presence. The United Arab Emirates is in talks for a purchase. Angola has expressed interest. The British Army is testing them. And here's the part that should terrify our adversaries. The production capacity exists to scale rapidly. GM Defense produces these vehicles in a 275,000 square foot facility in Concord, North Carolina. The same facility where they build diplomatic SUVs under a separate State Department contract potentially worth $300 million. They're not building these one at a time in a specialized defense plant. They're building them using automotive manufacturing techniques, the same methods that produce thousands of vehicles per day across GM's commercial operations. Remember what we said at the beginning? This represents the most radical shift in military procurement in 30 years. The US took the Amazon approach to military vehicles: fast, scalable, commercial technology adapted for military use, and by doing it, they've created a capability that adversaries simply can't match at this price point. Which brings us to what happens next. The ISV is already evolving beyond its original mission. GM Defense has built an all-electric concept using the E-Crate powertrain from the Bolt EV. Silent operation, reduced thermal signature, perfect for special operations missions where noise discipline matters. The Army is testing ISVs as control vehicles for robotics and autonomy platoons. One ISV towing a small multi-purpose equipment transport robot and hauling a steed cart, the silent tactical energy enhanced dismount platform. The future is human-machine integrated formations, and the ISV is becoming the quarterback. Other services are watching closely. The Air Force is evaluating them for base defense. The Marines, who've historically walked everywhere, are expressing interest. The National Guard sees them as dual-use vehicles for disaster response and military operations. And that Hurricane Helene mission we opened with, that wasn't a one-off. That was proof of concept. The ISV demonstrated it could deploy rapidly, operate in austere conditions, and accomplish missions that traditional military vehicles couldn't. The broader implication? We're witnessing the death of the traditional military vehicle development cycle. Why spend 5 years and billions of dollars engineering a vehicle from scratch when you can take proven commercial technology, adapt it in months, and field it at a fraction of the cost? China and Russia are still building vehicles the old way. Custom platforms, specialized supply chains, limited production capacity. The US just proved you can leverage the world's largest automotive industry to produce military capabilities faster and cheaper than traditional defense contractors ever could. The next arms race isn't just about the weapons. It's about how fast you can field them, how cheaply you can build them, and how quickly you can adapt them to new threats. The Infantry Squad Vehicle isn't just a truck, it's a blueprint, and the Pentagon is just getting started. Want to see more on cutting-edge military technology? Hit subscribe, because this is only the beginning of how commercial innovation is transforming the battlefield.